Let's solve this complex question in 30 seconds. What is the total number of structural isomers possible for hexane, C6H14? The standard textbook method is a massive time trap. You are taught to manually draw the straight chain, then draw branch chains, moving methyl groups around and constantly rechecking IUPAC names to avoid duplicates. It is very easy to miss one or count the same structure twice. Here is the 30-second shortcut, the alkane formula hack. For any alkane up to 7 carbons, you should never draw them. Just use this formula, 2 to the power of n-4 plus 1. Look at our equation on the right. Hexane has 6 carbons, so n equal to 6. 2 to the power of 6 minus 4 is 2 squared. 2 squared is 4. Add 1 and you get exactly 5. Option B is your correct answer. Notice the 5 distinct structures flashing in the center. Memorize the formula, completely skip the drawing and save your time. Let's solve this complex question in 30 seconds. What is the total number of structural isomers acyclic and cyclic possible for C4H8? The standard method is a classic trap. Students immediately draw the straight chain alkenes like butene, but they completely forget that this molecular formula also applies to cycloalkanes. Forgetting the rings will instantly cost you 4 marks. Here is the 30-second shortcut. The DU equals 1 split. First calculate the degree of unsaturation. 4 carbons plus 1 minus 8 hydrogens over 2 equals exactly 1. A DU of 1 forces you to split your thinking. It means strictly 1 double bond or 1 ring. Look at the right side. We split it up. For alkenes, we have exactly 3 structural isomers, 1 butene, 2 butene and isobutylene. For rings, we have exactly 2, cyclobutane and methyl cyclopropene. 3 plus 2 is 5. Option C is the correct answer. Do the DU split, count both sides and secure your marks. Let's solve this complex question in 30 seconds. How many straight and branched acyclic alkynes are possible for the molecular formula C5H8? The standard method is a mess. Students blindly draw 5 carbons and move the triple bond around. They often accidentally draw a pentadiene instead of sticking strictly to an alkyne, wasting time and getting the wrong answer. Here is the 30-second shortcut, the terminal internal branch method. Keep it strictly systematic so you never guess. First, draw the straight chain terminal alkyne. Second, shift the bond for the internal alkyne. Third, reduce the parent chain by 1 carbon and add a methyl branch. Watch the center screen. 1 pentene is our terminal alkyne. Shift it, 2 pentene is our internal alkyne. Now snap the chain to 4 carbons and branch it. 3 methyl, 1 butane. That's it, exactly 3 isomers. Option B is your correct answer. Reduce the chain, branch it and save your time. Let's solve this complex question in 30 seconds. What is the total number of structural isomers, alcohols and ethers for C4H10O? The standard method is to blindly draw carbon chains and stick OH or O groups everywhere. This creates massive confusion and you almost always end up drawing duplicate structures and losing time. Here is the 30-second shortcut, the radical counting trick. First, the degree of unsaturation is 0, so there are no double bonds. For alcohols, we attach an OH group to a butyl radical. Memorize this, a butyl radical always has exactly 4 isomers. Look at the center screen. The butyl group gives us 4 alcohols. For ethers, we split the carbons around the oxygen. Propyl methyl gives 2 isomers and ethyl gives 1. 4 plus 2 plus 1 equals 7. Option C is correct. Count the radicals, skip the drawing and save your time. Let's solve this complex question in 30 seconds. How many total structural isomers of aldehydes and ketones are possible for C4H8O? The standard method is a guessing game. You draw random 4-carbon chains and randomly place the double bond oxygen. It is super easy to miss a branched isomer or draw the exact same ketone twice. Here is the 30-second shortcut, the carbonyl radical split. The degree of unsaturation is 1, which perfectly represents the carbonyl group. First, for aldehydes, attach a formyl group to a propyl radical. Memorize this, a propyl radical always has exactly 2 isomers. Watch the center screen. The propyl group gives us 2 aldehydes, butanal and isobutanal. Next, for ketones, put the carbonyl in the middle. You can only split the remaining 3 carbons into an ethyl and a methyl group, giving exactly 1 ketone, butanone. 2 plus 1 equals 3. Option B is your correct answer. Split the radicals and save your time. Let's solve this complex question in 30 seconds. How many structural isomers are possible for the alkyne formula C6H10? The standard method is a nightmare. Drawing 6 carbons and constantly checking IUPAC names to ensure you haven't drawn the exact same branched alkyne twice wastes precious exam time. Here is the 30-second shortcut, the alkyne splitting trick. First, find M, which equals n-2. For 6 carbons, M equals 4. Now find all pairs of numbers that sum up to 4. 0 and 4, 1 and 3, and 2 and 2. Look at the right screen. We multiply the variations for each pair. The 0,4 pair gives 1 times 4, which is 4 terminal alkynes. The 1,3 pair gives 1 times 2, which is 2 internal alkynes. The 2,2 pair gives 1 times 1, which is 1 alkyne. Add them up. 4 plus 2 plus 1 equals 7. Option C is your correct answer. Learn the variation, split the pairs, and save your time. Let's solve this complex question in 30 seconds. Calculate the number of structural isomers for C7H12 alkynes only. The standard method is completely unmanageable. Trying to draw all 14 structures by hand takes at least 5 minutes, and you will undoubtedly draw duplicate IUPAC names under exam pressure. Here is the 30-second shortcut, the alkyne splitting trick. Apply the formula M equals N-2. For 7 carbons, M equals 5. The pairs of numbers that sum to 5 are 0 and 5, 1 and 4, and 2 and 3. Watch the right side. 0,5 gives 1 times 8, which is 8 terminal alkynes. 1,4 gives 1 times 4, which is 4 internal alkynes. 2,3 gives 1 times 2, which is 2 alkynes. 8 plus 4 plus 2 equals exactly 14. Option C is your correct answer. Never draw heptynes, just split the pairs. Let's solve this complex question in 30 seconds. What is the exact number of structural isomers for the alkyne C8H14? The standard method is to give up, but even students who know the shortcut often fall into a trap. Calculate 16 and get it completely wrong. Here is the 30-second shortcut, the alkyne splitting trick with a terminal twist. Apply the formula M equals 8 minus 2, which is 6. Students split 6 into the pairs 1, 5, 2, 4 and 3, 3. Using the variations, this gives 8 plus 4 plus 4, which equals 16. Watch the center screen. 16 is the trap. You forgot the terminal alkyne pair, 0 and 6. A 6-carbon radical has exactly 17 variations. 1 times 17 equals 17. Add that to the 16 internal alkynes and you get exactly 33. Option C is your correct answer. Never forget the terminal pair. Let's solve this complex question in 30 seconds. To quickly solve alkyne isomer counts, you must memorize the variations of alkyl groups. How many variations exist for a 6-carbon alkyl radical? The standard method is trying to draw and derive the permutations on the spot during the exam. You will definitely lose track, draw duplicates, and waste 5 minutes for a single mark. Here is the 30-second shortcut, the ultimate radical memorization table. Do not derive these. You must memorize the sequence. 1, 1, 2, 4, 8, 17, 39, 89. Watch the center screen. Let's build the table. For 1, 2 and 3 carbons, it's easy. 1, 1, 2. 4 carbons gives 4. 5 carbons gives 8. 6 carbons is the magic number. Exactly 17 variations. This single memorized fact unlocks massive questions like C8H14. Option B is your correct answer. Memorize the sequence and dominate the exam. Let's solve this complex question in 30 seconds. What is the total number of structural isomers for amines with the formula C4H11N? The standard method is a trap. Students randomly draw nitrogen chains without categorizing them, leading to missed isomers and accidental duplicates that ruin their score. Here is the 30-second shortcut, the radical classification split. Amines must be split into first degree, second degree and third degree structures. We then apply our memorized radical variations. Watch the center screen. First degree amines attach NH2 to a butyl radical. Butyl has 4 variations, giving 4 isomers. Second degree amines split the remaining 3 carbons around nitrogen. Prokyl methyl gives 2, ethyl ethyl gives 1, totaling 3 isomers. Third degree amines have 3 groups around nitrogen. Dimethyl ethyl is the only variation, giving 1 isomer. 4 plus 3 plus 1 equals 8. Option C is your correct answer. Classify, count the radicals and secure your marks. If you found this visual breakdown helpful, you need to put that knowledge to the test right now. Head over to neetat.in or download the NEET app today. We have chapter-wise, concept-wise and level-wise MCQs from easy to moderate to hard waiting for you to master. Plus, you can take free full syllabus mock tests, grab premium NCERT-aligned study materials and enroll in our ultimate NEET crash course to supercharge your prep. Don't just watch physics, conquer it. Hit that subscribe button, click the link in the description and I'll see you in the next video.